I'm going to finish up. A lumber company cuts boards that people use when they build decks. The company sells these boards in set lengths, but has to allow for some variation in the lengths due to the accuracy of the saws they use for cutting the lumber. The manager was studying this situation, so he used an electric ruler and measured several boards that were coming out of the saw. He listed the measurements in the table below. We've got two things that we've got to do. We've got to graph the information, and we have to have a scale and labels. And we also need the domain and the range of the function. I'm actually going to start with the domain and the range of the the domain of the function, x, and I am going to talk about the range as well. But what I'm going to do here is look at how this is actual board length is the domain. And I'm just going to go up to my table of values, and I'm going to go grab my smallest one. And I think these are actually listed smallest to largest. My domain values are just the x values out of my table. 7.75, 7.8, 7.85, 7.9. We don't have a 7.95. We go right to 8.1, 8.15, 8.2, and 8.25. Now the reason that was important to me and I started there is that I want to put, for my graph, I want to put actual board length down here. I want to label it down here on the bottom of my graph. The smallest board length that I'm dealing with is 7.75 and the largest one is 8.25. So I need to figure out a scale on my graph that's going to allow me to represent each of those values. I think I'm going to put a little break. I don't want to start at 0. I'm going to put a little break right here in my scale. And I'm going to start that right at 8.75. And I'm going to go up a quarter every time. I'm sorry, that should have been 7.75. 7.75. From 7.75, I want the next to be 7.8. I'm not going to write it because I don't think there's room. I'm going to just skip over where 7.8 would go, and I'm going to come here and write 7.85. 7.9 would be next, 7.95. 8 would be next, 8.05. 8.1 would be next, 8.15. And I'm creating a label. I'm labeling my axis 8.2, 8.25. And I actually have my minimum and maximum now here. I actually have my minimum and my maximum covered. I don't need to label my graph any further. What I'm going to do from this point then is go and look at what's the difference in the desired length and what I have. Difference in length. What's the smallest difference that's in my table up here? I think it's a tenth. There's my minimum. Hits a minimum of 0.1. And the highest it goes to is, it happens on either end, your maximum is 0.25. So I think probably the best way to go about graphing this is, again, let's make a little break in our scale. Smallest value, 0.10. Wonder if I can go 0.11, 0.12. I bet I can. 0.13, 0.14, 0.15 I'm skipping, 0.16, skip over 0.17, 0.18, 0.19, skip over 0.20, 0.21, 0.22, ooh, I'm pushing it, 0.23, 0.24, my 0.25 is going to be up top. I'm all right with that. At 7.75, I'm going to start graphing. 7.75, my board length difference is, at 7.75, it's 0.25. I'm going up and marking that on my graph. Done. At 7.8, it's 0.20. I'm marking that on my graph. At 7.85, it's 0.15. Drop it into my graph. 7.90, 0.10. At 8.10, it's also 0.10. At 8.15, it's back up to 8.15 is 0.15. This is nice and symmetric. 8.2 is at 0.20. 8.25 is at 0.25. There's your graph. 8 points is all you had to put on it.